everyone, welcome to Diksha Karnataka YouTube channel, and let us continue with the chapter electric charges and fields. I have already discussed the short theory recap. If you have not watched this, you can check that out after this video is over. And here I am going to discuss, as you can see in the screen, MCQs, the most important part where students makes mistakes because students do not understand how to answer a simple MCQ. So here I am going to discuss 30 MCQs from the chapter electric charges and field, which is very important for your upcoming midterm exam, because upcoming midterm exams 15 MCQs will be there, but there will be less number of chapters. So more number of questions are supposed to come from each and every chapter, and this is a very important chapter, so you can expect minimum 2 MCQs from this chapter itself. So without much delay, let us start with the first question. And obviously if you want to download this PDF and if you want to get any update that we are doing, you have to subscribe to our YouTube channel, as well as you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of this video. And now let us start with the questions. When a glass rod is rubbed with silk cloth will lose electrons, and glass rod will lose electron to the silk cloth. Glass rod acquires negative charge, silk cloth acquires positive charge. Now let us understand. So if you see the electric affinity table, glass appears first, silk appears later on. That means glass will lose electrons and silk will gain electron. Simple as that. But if you don't know that, then how can you answer? You don't know electron affinity table. So let us understand the points one by one. So only one of them can be the correct answer, that is the major part. So silk cloth will lose electron to glass rod. So if silk cloth lose electron, what will happen? If it loses electron, silk cloth will become positively charged, right? So silk cloth will be positively charged and glass rod will be negatively charged. This is simple. What will happen in case B? Glass rod is losing electron. So glass rod losing electron means glass rod is basically positive, whereas silk cloth is becoming negative. Right now, look at the option C. Glass rod acquires negative charge, so glass rod is becoming negative, and in this case silk cloth becoming positive, so silk is also positive. Right now, let's see which is unique. If you don't know the answer, just analyze the options in some cases, which is very essential to answer this type of questions. Okay, so if you see that option A, option C and option D are basically same options. So silk cloth becoming positive, silk cloth becoming positive, glass rod becoming negative, glass rod becoming negative. So these three options must be incorrect, because there is only one possible correct answer, so that is option B. So in case you are not sure about the answer, try to analyze it as much as possible and see that if any options are same or similar. Okay, similar in the sense exactly, for example, silk cloth lose electrons to glass rod is basically silk cloth is becoming positive and glass rod becoming negative. Now option C and D the same option, but they have separated the option A into two different parts. So that's why you have to be careful and see that, okay, option A, option C and option D are same, so that must be wrong answer. Okay, same answers does not necessarily means to be correct answer. So all of the three answers are same. That means whatever is not same should be the correct answer. That's how you can even answer the question which you don't know. So try to analyze it like that way. Next, question number 2. The electric field at a distance r from a infinitely long straight uniformly charged wire is. So we know that electric field due to a uniformly charged wire is proportional to lambda by r. Lambda is the line charge density, so we can say that electric field is inversely proportional to the distance. So inversely proportional to r. inversely proportional to r. Inversely proportional to cube of r, inversely proportional to square of r, both are incorrect, because to answer such questions you need to know the formula. Next question, which one of the following charges is not possible? Very interesting question. Now let's see the answers. Options: 1.6 into 10 to the power of minus 19. 0.2 you can ignore, that is a very basic part. So 1.602 or 1.6 into 10 to the power of 19 minus 19 is the charge of an electron. Right, this is a charge of an electron, so this is possible, this is quite possible. Now 3.204 into 10 to the power of minus 19, this is basically nothing but twice of E, this is also possible. Now 5.6 into 10 to the power of minus 19, what is this? This is actually 3.5 E. Now whether it is possible or not, we will come back later. And 6.408 into 10 to the power of minus 19 is 4 into E. Right, now if you remember the quantization principle, it says that any charge can be integer multiple of the minimum possible charge, that is E. Any charge will be integral multiple, that means this n has to be an integer. Now if you see that here E itself is an integer, because here we have 1 is an integer, 2 is an integer, 4 is an integer, but 3.5 is not an integer, it is a fraction. So that means this is not possible. So even though everything appears to be possible, if you look into a little bit deeper, you will see that this is 3.5e, which is not an integer, that means it is not possible. Now question number 4, the electrostatic force between two charges in vacuum is given by F is equal to K into Q1 Q2 by R square, where K is called Coulomb's constant and its value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. So basically you have to identify the correct unit. Okay, in this case also, if you are confused, you can check the options. Okay, if you see that 9 into 10 to the power of 9 we know, right? Now what will be the unit? Newton meter square per Coulomb square or Newton Coulomb square per meter square? If you see the options, there are two options having the same unit. Two options having the same unit, that means this unit must be the correct unit, and this is the correct value that we already know, so we can directly mark option A as correct. Now question number 5, the force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges. This statement is called principle of superposition of electric forces. Principle of superposition. Multiple charges, right? Multiple charges means principle of superposition. Right? The direction of electric field vector at a point on the equatorial line of a dipole is. So if you see that equatorial line of a dipole, if you consider the electric field is opposite to that of the dipole moment, right? Negative, positive, so it is opposite to that of the dipole moment. It is opposite direction to the dipole moment. Option B is correct. Question number 7, dipole moment is a vector quantity which is pointing from negative to positive along the axis of the dipole. Name the physical quantity which has the dimension formula LTA. So let us understand the dimension first. Okay, LTA, line charge density, capacitance, dipole moment or charge. Now if you see, if you know that dimension of charge is given by ampere into time or time into ampere. Ampere is basically the dimension of current. A is the dimension of current, right? A into T is the dimension of charge. Now what is the dimension? What is this L represents? L represents length. So length into A into T, lat or LTA. Okay, so basically this represents nothing but dipole moment. Why? Because if you remember, dipole moment is basically Q into 2A. What is Q? Q is charge. What is 2a? 2a is length. So length into charge is basically dipole moment. So it is the dimension of dipole moment. Dash placed in an electric field experiences a force in the direction opposite to that of the electric field. So if you place a charge in an electric field, it experiences a force in the opposite direction of electric field. So what is the nature of this charge? The nature of this charge, it must be a negative charge. Positive charge always experiences a force in the direction of electric field. Negative charge experiences a force in the opposite direction of the electric field. So it must be an electron. Electron is a negative charge. You can check the other options, but as we have figured out that it is a negative charge, that means it can be either a negative charge or an electron. Electron is obviously negative, that's why electron will experience a force in the opposite direction to that of the electric field. When a free electric dipole placed in an uniform electric field, the dipole will experience. So when a free electric dipole is placed in a non-uniform electric field, non-uniform, very important point to remember, non-uniform means it will experience a torque as well as a force. It will experience a torque as well as a force. So both force and the torque is the correct answer. Electrostatic field lines can never form closed loop. This is due to conservation of charges, conservation of momentum, quantization of electric charges, conservative nature of electrostatic field. The option correct answer is conservative nature of electrostatic field. Electrostatic field is conservative. So if you do some work to bring a charge from point A to B, and if you release it, you will get that get that work back basically. Okay, so the energy that's stored in the charge while doing work, if you release it, the same energy is released by the charge when coming back to the original position. That's why that is called conservative nature. Conservative nature means whatever money you spend, that money you can get it back. That is called conservative nature. Okay, there is no loss, nothing is being lost, that means it's conservative. Now, SI unit of electric flux. What is electric flux? Electric flux is basically basic definition is electric field into area. Electric field into area. Okay, and what is its unit? So obviously Weber is not the unit of electric flux, it is magnetic flux, but let us understand what is electric field. By the way, electric field is Newton per coulomb. Electric field is electric force per unit charge, right? Force divided by charge. So Newton per coulomb is the unit of electric field. What is area? Area is meter square. So Newton meter square per coulomb is the unit of electric flux. So Newton meter square per coulomb is, so see, if you see the option, you might be confused. Sir, Newton meter square per coulomb is not given. Actually it is given. So you have to be careful while answering the correct answer, because many students I have seen for such kind of answers, they by mistake, even though they know the answer, they by mistake answer the option D. Okay, because Newton meter square per coulomb, they see this is the correct order, so they have changed the order here, nothing else, they have changed the order here. So you might feel that okay, this might be the wrong answer, this is the correct answer. So be careful while answering such questions. Electric field intensity at a distance small r from center of uniformly charged sphere outside the sphere is E. Which of the following is correct? So uniformly charged sphere, electric field outside the sphere, it is inversely proportional to the square of the distance, and it is directly proportional to the charge on the sphere. So obviously option C is correct. Okay, it is directly proportional to Q and inversely proportional to square of the distance. It is like r square only, okay, not r2. Question number 14. The electric field due to an electric dipole at any point on its axis which is at a distance r greater than length of the dipole from its center varies according to E proportional to 1 upon r cube. E is proportional to 1 upon r cube. right? Electric dipole moment, be it on equatorial plane, be it on the axis, okay, anywhere it is located, in fact anywhere it is located, as long as the distance is more than that of the length of the dipole, okay, it is always E proportional to 1 upon r cube. Now this is a matching question. Match the following type question. Some physical quantities are listed in column 1 and the SI units are listed in column 2. Identify the correct match. Okay, electric field, Newton per coulomb. Now there is one more unit of electric field, we will come to that in a while. Okay, now permittivity is easy. Permittivity is Coulomb square Newton to the power minus 1 meter to the power minus 2. So that is permittivity. Now electric flux and electric field, that is very very important to identify. One of them, you know, electric field. Once your next chapter is completed, you will know about the another unit of electric field, which is volt per meter. Okay, volt per meter is the unit of electric field. Now if you match any two of them, your answer is done. Okay, and electric flux is electric field into meter square, that means volt into meter, it's electric flux. Okay, so this is the matching. Now let's see the correct match. So 1 is matched with B, 1 is matched with B, 2 is matched with C, 2 is matched with C, so option A is correct. Option A is correct. 1 is matched with B, 2 is matched with C, 3 is matched with A. In fact, if you just know 3 is matching with A, you will be able to answer this question, because if you see all the matching, no, there are two options, either this one or this one, then you have to identify. Okay, sorry, my mistake. So in some cases, in some longer matches, they will give you such a match that where you, even if you do one correct matching, you might be able to answer it based on that particular match. So be careful and try to be little bit intelligent about that and answer such questions. Now question number 16, it's a statement based question. Statement 1, the electric field lines never cross each other. Correct statement. If electric field lines cross each other, the field at the point of the intersection will not have a unique direction, which is not possible. Yes, correct explanation as well. So both statements 2 and 1 are correct, and 2 is the correct explanation of statement 1. So option A is correct answer for this question. Let us continue to the next question. 4 charges are placed at the corners of squares PQRS as shown in the figure. The direction of the resultant electric field at the intersection of the diagonal is. So here you don't need to calculate the electric field, but you need to find the direction of the electric field, which is very very important to understand. So if you see that what are all the charges given here? Plus 2, plus 2, plus 2, and only 1 minus. 3 of them are plus, only 1 is minus. Now if you see that this is a plus charge, this is also a plus charge. So diagonally opposite plus charges cancel each other. Okay, so if the you are trying to find the electric field at this point, center, right? So electric field due to this will be in this direction, okay, Q, and electric field due to S will be in this direction, away from, right? Positive charge electric field is always away from, right? So these two are both charges are equal, that means they will cancel each other. Now electric field due to this will be in this direction, okay, P, and electric field due to this negative charge will be also in this direction, R, because negative electric field are always towards, right? So they will not cancel. So the electric field is towards OR or CR, okay, or it is towards R. So electric field in this case is towards R. So towards R is the correct answer. Next question, the following figure shows electric field around two charges where, so you have to determine whether the charges are positive or negative. So if you see these two charges carefully, you see that all the electric field lines are actually going out. So all the electric field lines are going out. For both the charges, electric field lines are going out. So if the electric field lines are going out, that means what? So if you see that arrows are going out. So it is they must be positive charges. So this is a positive charge, this is also a positive charge, right? Both charges must be positive. So Q1, Q2 both are positive. Okay, so both charges are positive. Next question. Which of the following shows the electric field lines due to an electric dipole? So electric dipole basically have two charges, both are equal charges but opposite in nature. So whatever electric field line generates from positive charge, that should go and meet the negative charge. So if you see the diagrams, you will realize that this must be a positive charge and this must be a negative charge, and all the field lines are going equally from positive to negative. Now this is also a similar arrangement, but here charges are not equal. Charges are not equal in magnitude. If you see the diagrams carefully, okay, the lines are not uniform. Okay, so they are actually going like this. So these two charges are not uniform, that's why this is not a dipole. But here if you see that the diagram is uniform, that means this is the dipole. So correct answer is option B. Correct answer is option B. The given figure is related to Gaussian law in electrostatics, phi equals to Q by epsilon naught, where Q is equal to. So you have to find the Q in this given case. So if you see that this is the Gaussian surface, this is the Gaussian surface, and in case of Gaussian surface, Gauss's law, only the charge which is inside the Gaussian surface that we will consider, right? So what are the charges inside? -2 and +8. So -2 plus 8, that is 6 microcoulomb. 6 microcoulomb, and it is positive. 6 microcoulomb only we have to consider as Q. These two charges are outside the Gaussian surface, so we will not consider them. Next, charges are conserved for open system, isolated system, any system, no system. Charges are conserved only for isolated system. It is not conserved for any system. The SI unit of surface charge density. So surface charge density is basically charge divided by surface area. So it will be coulomb per meter square. So coulomb meter to the power -2. So coulomb meter to the power -2 is the unit of surface charge density. SI unit of electric field. SI unit of electric field, Newton per coulomb, okay, or volt per meter. Newton per coulomb or volt per meter, both are units. Here voltmeter is given. Voltmeter is unit of flux, not electric field. The angle between the dipole moment and electric field at any point on the equatorial plane is. So angle between dipole moment. So dipole moment is in this direction, electric field is in this direction. How to find the angle between them? Equatorial plane, right? So this is the equatorial plane. To find the angle, what you have to do? You have to draw both the vectors from a single point, right? And what is the angle between them? The angle between them is 180 degrees. Next, the electric dipole placed in uniform electric field is unstable if the angle between the electric field and the dipole moment is. So electric dipole placed in an electric field is unstable. So for that we have to remember that the torque acting on a dipole is given by tau is equal to P sin theta. Okay, now unstable means if it is located at any angle theta, if you release it, it will start oscillating. Now if you see that sin 0, what is the value of sin 0? Sin 0 means it is actually 0 degrees, so torque acting on it is 0. Now sin 60, it is unstable, okay, but not in equilibrium. Okay, 90 degrees means sin theta is 1, so it is torque is maximum, but again it is not stable. 180 degrees, if you put 180 degree, again you will get a negative value minus sin 180 degrees. Sin 180 degrees 0, So it is a equilibrium position, right? So 180 degree, sine 180 degree is 0, not minus. Sine 180 degree is 0. It is equilibrium position, but 180 degree, even though it is an equilibrium position, it is an unstable equilibrium. It will, if you move it just by a small angle, it will start oscillating. So it is an unstable equilibrium. The question should be unstable equilibrium, so that there is no ambiguity about it. So question in if you see the question, it will come about unstable equilibrium only. So at theta equals to 180 degree, the dipole is most unstable. Okay, the SI unit of electric flux is, so SI unit of electric flux as I said is E into A, so it is Newton per Coulomb meter square. So this is the answer. Coulomb's law of electrostatic agrees with Ampere's law, Newton's third law of motion, Ohm's law, Faraday's law. Now you answer the question. Is there any relation with Ampere's law? Ampere's law is in current electricity, but is there any relation with Ampere's law and Coulomb's law? You have not heard. Ohm's law? Never. Faraday's law? Never. Newton's third law of motion, on the other hand, have a relation that whatever is the force this charge is applying on this, the same amount of force is being applied by this charge on the other charge, which is reaction and action and reaction forces. So whatever force this charge is applying on that, the same amount of force is being applied by this charge on this. Okay, so action reaction force, so definitely Newton's third law of motion. Electric field inside a spherical shell is 0. Electric field is 0. Electric potential we will learn in the next chapter. Charges are conserved for isolated system. The total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by that surface. This is the statement of Coulomb's law of electrostatics, Gauss's law of magnetism, Gauss's law in electrostatics, Ampere's circuital law. We all know that this is from Gauss's law in electrostatics. So we have completed 30 MCQs in less than 30 minutes. So congratulations to all of you, those who are be patient and follow through the entire lecture, and please mention in the comment below, sir, I have completed the entire all 30 questions. And also I will be back with the 2, 3 marker and 5 marker question including numericals from this chapter after this lecture very soon. Till then, bye.